Here's Mark Bayley.
Thanks, Tony. I've just had a great introduction from all the speakers this morning. It's all kind of segued into this presentation, I feel. The ordering of the presentations has been unreal. Peter alluded to landscape scale wetlands. We talked about processes within constructed wetlands and hydrology and all that kind of stuff. And I'm going to hopefully bring it all in and talk you through the idea of landscape scale wetlands, because they can be much more cost effective and you can actually potentially kick a few more goals sooner than if we have lots of little constructed wetlands. So just before I get too far into it, for those of you that are having trouble with the term landscape scale wetlands, this is what we mean. This was all old sugarcane land that was drained and farmed extensively. It was too low in the landscape for sugarcane, so then they subsequently grazed it. We had a lot of acid sulphate soil runoff, and essentially, like this is in New South Wales, northern New South Wales, but it's a really good example of what minimal works you can do on ground to get great environmental outcome. So we blocked a few drains and did some strategic weed management, and we managed to get a 200 hectare parcel of land largely revegetated. The driver for this was wetland rehab and habitat reasons, but there's a lot of obviously water quality benefits that come out of that. And I'll have some examples in northern Queensland as we move on. But that's kind of what we're talking. Rather than building, little ones down here attached to this little cane farm, we're like, let's just do a big chunk right at the end. The rationale, I think, today, in many respects, is driven by cost. So if we look at traditional stormwater wetlands and smaller things, you're looking at, just from a planting point of view, put aside the earthworks and the engineering, to get that really dense macrophyte growth that you need to get the treatment that we all want, we're talking 6 plants per square metre at $2 per plant in the ground. A 1 hectare wetland can cost, just from the planting component, $120,000. Now, if you look at landscape scale wetlands, quite often you don't need a plan at all. All you need to do is reinstate hydrology. And this is a picture of the before and after of that same wetland from the slide ago. And all we did here was block some drains and reinstate the natural hydrology. And because there was a natural seed bank there, everything just came back to life. In terms of cost per hectare, we can really start to get a lot of runs on the board. And you can see just from a density point of view, we're going to get those biological transformations of the dissolved inorganic nitrogen up into the gas. So you would reasonably expect that would become a really good treatment wetland if we can move flow through it, which is obviously the next challenge. A lot of you obviously will be aware of the issues that we're facing. This is a lot of photos taken from around the Bundaberg region. We've done a few projects around there. So there's a lot of sediment transport, there's a lot of improvement on farm that can happen as well. And obviously this is what we get downstream. These are the paddocks, these are the pathways to the waterways, and this is kind of what we're ending up with. So this is probably more for the people within Brisbane that aren't getting up into the wet tropics or the dry tropics a lot. This is kind of what we're dealing with on the ground. And this is obviously in rainfall events. Quite often you go out there to do your concept design or whatever, and it's pissing down with rain. So you're trying to make things work. It's a great way to assess a site, but it's also difficult to write notes and survey the site and everything. So again, the theory of the landscape scale wetlands in this context is essentially recreating a traditional floodplain wetland to perform water quality treatment functions. If we take a step back, we know that before we came and drained the landscape and built our towns and Alphas and all that, there was a natural connection, a hydraulic connection between the floodplain wetlands and the rivers. And that kind of connection drove a lot of diversity and production with the biology of those floodplain wetlands, and then that interaction in turn removes inorganic nutrients. It's the whole reason why constructed wetlands are a thing that we're talking about, because we've kind of harnessed that ability of a wetland to process nutrients. We're packaging them up into a constructed sense and we're building them. We've been doing it for 20 years. Peter Breen's been doing it for a long time, probably the longest in this room. And now I feel like there's a shift of going back to the landscape scale, because I think that's the scale we need to be working in for significant improvement for the Great Barrier Reef. I mean, obviously it's not not going to be the silver bullet, but it's going to be part of the solution. While I was tooling around the net trying to write this presentation, I came across some studies that found that obviously there's good connectivity. I mean, this is, you know, not that riveting, but there's really good connectivity between the rivers and the floodplain as they exist now, and for a range of different flood events, so the 1 year, the 20 year, all different rainfall events, and that inundation frequency is obviously dependent on bank height, elevation, levees, and that all controls the magnitude and frequency of the flooding of that particular floodplain wetland. So if you can just hold on to that thought, we've done a design for a system right at the end where we talk about a connectivity. I'll talk about a case study. What I'm trying to present or to talk about here is kind of recreating the hydrology of a potentially degraded wetland site that might be on marginal cane land, rehabilitating the vegetation, and what we get then is, I guess, a floodplain wetland that can reduce pollutants but also has a lot of other multiple benefits. So you're talking about recreation, habitat, potentially carbon sequestration, because we're talking more floodplain forest, so you're talking Melaleuca wetlands, Casgorka, that kind of stuff. This is a wetland up in Babinda, so we've moved into Queensland now. So this is Babinda, Bundaberg's over here, and this is the pasturage reserve, if anyone's familiar with it. And it's a beautiful, it's amazing that it's actually there. So it's a beautiful Melaleuca delbata floodplain wetland. It's crazy that it's just not a tapestry of sugarcane plantations. And you've got the modern proposed turtle rookery just there, which is probably its saving grace. If the turtle rookery wasn't there, this probably wouldn't be there. So in a previous life, we did some work, and what we ended up doing, very, very simple, and this is where you can get a lot of bang for your buck. There was 2 big drains going through it, one just draining this whole landscape that way, and this is what the drains look like. And we ended up somewhat blocking those drains very crudely because we only had $5,000 or $10,000 or something like that, not a lot of money. And that just pushed a lot of the event flow out onto this floodplain wetland. And through there you had a lot of Aleocaris beds, so a very, very diverse habitat. And what we got is essentially in a flood event, it just started to move across this landscape and across this landscape. So essentially you got treatment through vegetation. You also got treatment through infiltration of the soil back into the groundwater, so you're reconnecting that floodplain hydrology. I don't know how well that worked because there was never any monitoring or follow-up, but it was a very cheap kind of way to reconnect that floodplain. So that's the kind of things we're talking about. If we compare them to what Peter and Tom have been talking about, just in a kind of simple table, landscape scale wetlands are generally very large as opposed to traditional stormwater wetlands in the agricultural context. They're generally on farm level for the smaller constructed wetlands, whereas landscape scale can operate at a whole of catchment or just a very large catchment or sub-catchment level. The pollutant removal processes are all very similar. With landscape scale wetlands, and particularly that one at Babinda, you've got a lot of infiltration through the soil profile, so you're getting that kind of groundwater recharge that Grant talked about earlier. I think some of the advantages are that you can treat large catchment areas at a much reduced cost per square metre, and you can get like multiple benefits, really measurable multiple benefits. You can get the community involved probably at a much greater level. You can put bird hides and walkways through them. They're much probably more amenable to the multiple benefits than the smaller constructed wetlands. You can also use marginal cane land. So there's obviously a lot of situations where back in the start of the cane industry and drainage was promoted through the drainage unions all through New South Wales and Queensland, a lot of lower landscape got drained and farmed, and then subsequently over many, many years it just got abandoned because it was marginal land. So we can use that, I guess the negative outcome of that farming legacy as a positive in terms of our rehabilitation of the reef catchments. I think our disadvantages with landscape scale wetlands is that it can be difficult to find the sites, and you do need detailed modelling to figure out how much flow you're going to get through that wetland. Are you going to flood the neighbour's farm? Because you're talking big 10, 20, 30, 50 hectare wetland systems and big flows. You don't want to flood the neighbour's cane farm or flood houses and stuff like that. So you do need some pretty detailed hydraulic and hydraulic modelling to run them. So in terms of design steps, I think it's very similar design steps for traditional stormwater treatment wetlands, with the exception of environmental rehabilitation plans. So I kind of, normally in a standard stormwater treatment wetland you have a planting plan, and it's very prescriptive these days on how you do it and what you should do, generally speaking. I think when you're talking about landscape scale wetlands, the whole idea of a planting plan, in my mind, needs to be thrown out the window, and you want to talk about a rehabilitation plan, because that's where you're going to save a lot of money, and that's where you're going to get a lot of multiple benefit. You've still got the treatment zone design, which forms part of the environmental rehabilitation plan. You've still got inlet and outlet systems you've got to organise and figure out. You've still got construction and establishment you've got to worry about, and there's still maintenance. It might not be as much, or it might be more, depending on the situation, but the same design steps generally follow. So I'm not going to talk about all those other steps because we've talked about that in the previous presentation. So I want to talk about landscape and rehab design and how we can design a landscape scale wetland so we don't have to plant 6 plants per square metre. And the big one, and Peter touched on it in his presentation, was the inundation assessment. And in my experience with constructed wetlands, I visit a lot that don't work. And I think a lot of people, if people are from council here, they might have a similar experience. And in my experience, that's all about the inundation regime of that particular design has driven the plant community to fail. And generally it's too wet. The inundation assessment, and that's a hard thing to do because you're talking about a fictitious wetland that you're going to recreate. So again, we have to use modelling to help inform that, and we need really strong ecological advice and assessment of that particular parcel of land. So it's really a blend of hydrology and hydraulics with ecology. In my mind, form that plant selection if you actually have to plant, or that rehabilitation plan, which is, I think, in terms of your site selection, that's where you want to be directing it. You want to find a site that you rehabilitate as opposed to replant. I'll skip through those next ones. In terms of bathymetry and inundation, what we like to do is come up with a profile, a broad, this is how deep the wetland's going to be, and this is where the levels are, and the sediment basin's this deep and the plant zone's that deep. Let's run some water through it and see what the height regime is. And this is a different way of displaying the same data that Peter displayed earlier. I do it in days per year at a given water level. My brain works a bit better that way. And you can see that if this is our design water depth, this particular bathymetry design is just not going to work. It's too deep for too long. So we muck around with our inlet and outlet structures until we get that right. Even though landscape scale wetlands are more about ecosystem rehabilitation, if they're to perform a treatment function, you really do need to have that whole bathymetry and water balance and inundation as well. So we'll get on to throw the theory away now and get on to some exciting stuff. Construction was meant to start earlier this year, but it didn't happen. It was too wet for too long, so they're just hitting the ground running now. So this is up in Brisbane, so just south of Cairns, north of Tully, I think. So it was a 45 hectare parcel of land that we had available to us. So we had this parcel of land. It was 45 hectares in size. It was about a 200 to 300 hectare catchment, and this is the Russell River running through here. A massive amount of rainfall, as you could imagine, 2,500 hectare catchment. Sorry, so the wetland design was about 1 to 2% of the contributing catchment, and that wasn't necessarily a modelling output. That wasn't necessarily decided. That's how much we needed to. It was more like that's how much land we've got. And that's where it has to be, so make it work. Which is quite often what consultants get, is here we go, make it work, thanks very much. The site selection was done before we became onto the project, and that was the combination of obviously stakeholder endorsement, stakeholder liaison, all that kind of stuff. And basically it was just a clapped out bit of cane land that was too low in the landscape to be productive for the farmer, so he just walked away. And again, the design principles for this particular project was reconnecting the floodplain, recreating ecosystem processes, removing sediment and dissolving organic nitrogen. Obviously we couldn't hinder any farm operations or reflood neighbouring farms. The catchment was strongly managed by the drainage union. It had a big main drain running all the way through it. We had to work with the drainage union to make sure we didn't back water up and flood farmers that weren't supportive of this idea. And obviously we just hoped to add general value through water savings, harvesting of water in their dry season if they needed it, and obviously protection of topsoils. In terms of site selection, I've kind of touched on it. There was a range of agencies involved and local groups, and what generally we've found is it you don't necessarily get the site that is the best one for the environmental issue or the problem that you're trying to address. It's normally what's actually available, and it might not meet the best environmental outcome. It might only get 60 to 80% there, but someone's willing to give you the land for nothing. All the other landholders around it are okay with it being there. So basically that's the kind of spot of land that you've got to work with. And like I said down here, ultimately factors in my experience, other than the best environmental outcome, will kind of guide where the site is. This is the big drain, the main drain. This is the Russell River through here. So it was huge big drain with levee walls on either side. And then we had typical cane drain kind of farming situation where you had a lot of parallel drains feeding into another drain, feeding into the main drain, all with floodgates everywhere. This is the main picture of the main drain here. These are the levees. This is an interesting site assessment actually because there was crocodiles everywhere. I actually have traipsed around wetlands much when there's crocodiles, have to be on the safe work method statement. But I was quite scared actually. We had some Koori fellas with us and they didn't care at all. I had to go down there and get a water sample, so I had spotters up there and I turned around when I was taking my water sample and they weren't even there. That was a funny day. So this is the main drain. We had a lot of little feeder drains, and that's Aleocaris in there with, I think, Blechnum. And then these drains fed into this drain, Persicaria there, which fed into that drain. So what we're starting with, in my mind, is a pretty good start to a constructed wetland. We've got a lot of good plants. Like if you were to plant that out in an urban constructed wetland like that, would $2 per plant, $6 per square metre, there's probably $200 just there. Plus monitoring and maintenance. So all of a sudden, I think we're in front of the 8 ball, and all we need to do is reinstate a bit of hydrology and a bit of floodplain connection, and admittedly we'll probably lose that Aleocaris there, but it'll probably start occupying all this area because this has been laying down a seed bank for a long, long time. And the reason it's like this is because he walked off farming cane 20 years ago and it's gone through that weediness stage, and I've done a few burns on it, and all of a sudden things are starting to come back. There's a lot of design challenges and what we're trying to recreate. Because we're trying to recreate nature, we can't necessarily put a marsh where it's not going to grow hydraulically. So we sectioned it off with LiDAR and said, well, this is where we're going to get our actual emergent macrophyte zone. So this is going to probably best emulate a treatment wetland. And essentially, if you do look at it conceptually, this is what we had. We had a kind of a paddock down there that was really well drained into that main drain with big levee walls. And essentially we reprofile this drain. We can pipe some water in through here and reflood this whole area and try to get those nutrient transformations that we know occur in treatment wetlands, both natural and constructed. I can't show you any construction photos because it hasn't started, but this is the detailed design stuff. So we pipe it in through here and it basically moves in through these. We use these existing drains to push the water up laterally through and across this way, and then we brought it back down through here through outlet devices, back into this channel and back into there. So there's no planting at all in this constructed wetland. It's all about, this is an access maintenance track. It's all about this and this. So you've still got the inlet and outlet zone and the rehab, and these levels got set by what plant community we wanted to develop there. You're probably going, how much flow does it treat? So what? This is where the hydraulics came in. I'm not a hydraulic modeller, but it got done, and we think anywhere between 1% and 3% of all flows from that going down that drain will make it into that wetland for a certain percentage of time. And there's a fair amount of data there. How much will it reduce? We think about 40 to 50% of dissolved inorganic nitrogen. This is just modelling. They will start monitoring it to actually see whether this is accurate. But it's kind of hitting that 2% that Tom mentioned. Sorry, Peter, you said 10%. This is about 2% of catchment, about 50% nitrogen reduction. But they're the numbers we need to figure out. So we know what's somewhere between 2 and 10, and 50% DIN is what we want to reduce it by. And there's just a couple of pictures from random sites. These are the kind of stuff you can do when you're reconnecting floodplain. You've got drains like this everywhere. You put a weir in there, a drop board weir, that pretty quickly floods, the neighbouring paddock down there, and pretty soon it can turn into something like that without actually any planting. So that's it.